not include for the notional load, but for the nonlinear analysis second order p-delta effect, you must to include the notional load. Now in load combination, we do not include the notional load. We run the first order analysis first to check and verify the section and the lateral twist to make sure the structure is stay in a low ball twist. Click on analysis. Run analysis. Okay, now we can continue to analysis stage. In the case we do not use p-delta option To make sure I want to delete this option, I use NAND to run in linear analysis, and we also create another load cache for the backlink. This one we had to verify the structure if had to run in second order analysis or not. So you have to run to check the critical load vector. Add new load cache. And this one I call it critical load, and change it to the backlink, critical load backlink. And the version of PData, in this one we do not use PData, use non-linear load cache. We do not have non-linear load cache. Okay, add. Now we can add load, did load, add. You can add line load, vintage. Now this one I want to check about the did load, line load, and win load. Okay, now let's check, input it 1.35. This one is 1.05. This one is 1.5. This is backlink load. No. This one is not notional load. This one is the win load. I call it critical load vector H. And number backlink, you can type it 10 or 12. We want to focus about backlink mode 1, 2, 3. Click on OK and add copy load cache, critical load backlink. We have to check about another load backlink direction Y and compare each other what is different. Change it to Y backlink. This one we have to change the win 8 to win 8 to win Y. Click on OK. Click OK. Now after complete, you can check information and animation of the building. Now let's check about animation. To model shape. Okay, mode 1, model 1, number model, you can increase it. Now we have to check the first mode shape. Okay, now you can see here mode shape and period 2.54. now it acceptable. Now click on start animation. Okay, you can check for displacement we set. Now we want to check about the story trees. You can check for the display, story response plot, okay. And the displacement type, max story displacement, and load combination. We click on the check in the load combination. Now we don't have load combination in service. You have to add and check in the service. Now let's check in load combination bin H. Now we check only load cache bin H. The maximum displacement for all story, maximum displacement, 8 direction, and you can show high plot parameter. And region type integrated. For the blue is the 8 direction, and for the white red is y direction, and maximum story displacement in 8 direction. 8 direction is maximum 78.31 millimeter. Okay. And now let's check for the wind y. Is 78.51. Now let's check with the low ball or the bidding high is h over 500 or over 400. Now our bidding is 3 multiplied with 32. The total height is 96 meter. Divide by 400 is 0.24 is 0.24 meter. So W of the tree show the wind in both directions is acceptable. Yes, this one is maximum is 78. Yes, 78 millimeter. Allowable is 0.24 meter, equal to 240 millimeter. Now let's check for the story max story tree. You can check for max story tree. Come back, check now displacement, and we have to check in the load combination circuit. where is load combination service. Now we have to add load combination. Define load combination. I have to add new load combination. I call it SLS load, and this one we apply for the wind in 8 direction, and this one is the line load, and we use the line load only 0.6 for the maximum displacement to the wind load. SLS wind 8 plus wind 8. Okay, and copy load combination SLS plus wind Y. I change it to the Y direction. Now let's change the load combination to the come back to display response plot. And max story replacement, check for the load combination. Where is load combination? Okay, SLS with H, SLS with Y. Okay, now check for the SLS with H. Okay, this one. Okay, W is suitable and SLS with Y. Yes. Now the maximum is 77.66. So is maximum displacement we compare with the allowable H over 400 is suitable for the overall twist. And you can check for the drift from one floor to one floor to make sure it is suitable. This one is the max story twist. Yes, max story twist. In the Y direction. This value also suitable, and in 8 direction. You can check for auto lateral load to diaphragm. Yes. Win 8, win Y, and load set to load set 1. You can check for the auto lateral load to the stories. Okay, now let's check for the critical load vector. Click on Analyze, Display, so table, Analysis, structural output result. You can check about the model information. Now we have to check about period. Okay, model, period, and frequency. Click on this one, select load. Okay, load case, we select it all, and load combination, click it all and click OK. Now you can check here the mode shape 1, mode shape 2, mode shape 3, mode shape 4, 5, 6, 7, 8, 9, 10, 11, 12, and the period is 2.52, and the frequency per second is 0.39. So this value is very low. We have to increase the value at least 1. So for the model 3 is acceptable, we have to increase, add more wall and more thickness to our frame, and to increase the natural frequency. In this period, frequency okay. If you use the formula, you can calculate frequency is equal 1 over t. 1 over t is 1 over 2.547. And for the model 1, mode shape 1, and for the mode shape 2, you can use the same 1 divide 2.371 is equal to 0.4. So in the two mode shape, okay, frequency not acceptable, so we had to increase the thickness to our structure. Now let's check for the overall tree is acceptable, and for the natural frequency is not acceptable. And now we check for the buckling load. To display, so table, now untick here, and analysis join, where is the structure output, the output buckling load vector. Click on buckling load vector, select load combination, okay, okay, click on OK. Now for locate buckling X, buckling Y, the mode 1, mode 2, mode 3, and scale factor is 18.64. So the value is acceptable. We can run in the first linear analysis, do not need to run in the second order analysis for the load buckling factor. For more detail about this buckling factor, you can check in my tutorial discuss analysis and design, and Etabs run big data and small big data, and the tutorial 3 in manual verify with the critical design. I also talk about the amplification factor, or in a tab we use the critical load factor. Yes, critical load factor lambda CR. So if you can input it calculator. Now I just verify it quickly. Is equal to 8. Now it's there. Is equal to 18.643 over 18.643 minus 1. Sorry. Yes, this value is over 10%. No need to run in the second order analysis. You can run for the first order analysis. This load buckling factor, we run for the load buckling factor 8 and 5, so you can add another load combination factor for load buckling to run a buckling. This one we focus about the critical load buckling 8 and critical load buckling y include load combination. You can check about load combination. Defined load combination buckling where no is load case. Define in load case. Yes, this one, and modify. Yes, we use this load combination to verify for load combination buckling factor. So you can create other load combination 1, 2, 3, 4, 5, 6, 7, and to verify the critical load factor. This one I use only 2 this load combination. Click OK. Click on Save. For the structural irregularity, torsional rigidity, no need to verify because our structure is symmetry. And for the source story, also no need to verify because from one floor to one floor we know the thickness over 70% or 78%. So we can say that we don't need to verify for the torsional rigidity and the story source. So now we have to improve our structure again, the natural frequency, and after we add other new wall, and we can rerun it again and verify natural frequency, and we can continue run analysis and design in linear analysis. Now we let jump to the design. This one we use the UK national NH and load combination equation 6.10 is correct. And for the column we can design in nominal curvature or nominal stiffness. Click and OK. Click on design, concrete, select combination. OK. Design, concrete, start design and check. Now let's check for the linear analysis. All column pass, and for the wall we do not yet run analysis in design for the wall. Now we want to check for the column, and now you can check for the column. Click on one column and right click. The design control load combination is the did load minus 1.5 wind load in the y direction. In the y direction, this one in the x direction, in the x direction, in this direction, and in y direction in this direction. So the control load combination did load plus minus 1.5 so we load from this direction, okay, opposite in the positive direction, in the minus direction, and right click, detail, check for the envelope, and control grow column section, column length, and the SAK, the design the load for the ultimate load is 9297.53 kilonewton, and the moment M2 and M3, the final moment is 371, and M2 is 216.94. The control load combination is here, and the control load combination station, it has a different station 0 and this station 2.3 meter. Control load combination is 1.35 the load, 1.05 the load, plus 1.5 in each direction, and imperfection section moment, yes, the final moment 371.9 kilonewton met. For the first order analysis, this one we do not yet include the second order analysis and global infection and local infection. Click OK. Analyze, display, so table, model, low pass pressure model, direction vector, period and frequency. Again, yes, frequency, this value is in F or what? Okay, period in a second, so yes, this value in F. So in F we have to remodel or to add more stiffness to our structure. Although our structure can design to receive the load, but we have to increase the stiffness to receive to increase the natural frequency. Okay, and change value, cycle frequency, region per second, frequency cycle per second. So now it's sure you have to increase the stiffness. Okay, thank you for your watching. This is the basic step we have to verify about the global trees and local tree. Local tree you have to verify from the one floor to other floor, and natural frequency and the member. This one we do not yet focus about the wall. We focus about to have a spot check, not focus about the wall, the beam. So this is the way we can check the first in the structure, and for more detail we will focus design on each element details. Thank you for your watching. We will check for other new material, new tutorial. Thank you for your watching.